Okay, we'll start today with a quick review from yesterday because we covered a lot yesterday. So we're going to start with a quick review and then add in a little bit new. We won't add in a lot though. Let's shoot for less than an hour. Okay, we'll shoot for less than an hour. Someone remind me if it's going too long. I follow this YouTuber, and he always says, we're going to make it a quick one today. And then it's like 45 minutes later. And it's like, that is not quick.
I feel like that's every developer YouTuber. Yeah.
We're going to do a real quick one today. 3 hours later. It's like, come on. But I suffer from that problem myself because I was like, oh, we'll do this real quick. And then it's a 2-hour thing. Okay. Let's review from yesterday. So, a class is a blueprint of an object, right? You create the blueprint and then you create the object. So you got to create the class first. A class is or a blueprint is an abstraction of a real world thing. So when I say an abstraction, we're taking the real world thing and getting it into computer code. So how do we take a real world thing and get it into the computer, into computer code? Okay, so yesterday I said, give me an example of a thing, and the thing we said was a car. Today I'm going to ask the same question, give me an example of a thing. What thing are we creating today?
A dog.
We're creating a dog. That's the first thing that I heard. So we're going to start by right-clicking, adding a class, and a real-world thing is a dog. Now, notice I'll type in dog.cs. Capital D is the convention. Classes should be Pascal cased, and we're going to change this word internal because we'll make it public. There is a difference between public and internal, but for right now, let's just make our classes public. And what are the two things, generically speaking, that you kind of break down? Really, I say what are the two things, but I started with two and I added a third. So we'll say what are the three things that a class can have?
Attributes and methods.
Beautiful. Attributes and methods. And those were the kind of the two things that I started with yesterday. But then I added a third thing, which was, do you remember?
Getters and setters.
Well, methods, if you give these a name, these were our getters and setters.
Properties.
There we go. And properties. Okay? Now both methods and properties did the same thing. They worked with the data. The data being the attributes. Okay? And so when I say you work with the data, primarily you're doing two things. You're putting things into the data and you're pulling information out. Like you're modifying the data or you're reading the data. So let's talk about some dog attributes. Give me one dog attribute. We'll just start with one.
Breed.
Breed. I'm going to make our field, okay, an attribute is a piece of data. A field is a variable that is marked as private. Okay, our instance fields are our attributes. That's our data. Our instance fields underscore breed is a variable, but every dog that we create can have a different breed. Now, many of them might have the same breed, but each instance of dog can have its own unique breed. So we're going to start with breed. Now, the first thing we learned to do was make a getter and setter. Okay, so a setter puts data into the breed. The getter reads the breed. So it's like read and write operations. That's all these are, read and write. Think of getters and setters in read and write operations. So I'll code this up real quick. Public, the return data type is string. We'll call this get breed. Return underscore breed. That is obviously the getter that's going to read the data. This is the read operation. Public void set breed string breed underscore breed equals breed. So these are two methods. These are two methods that we're going to use to work with this variable. The reason we're doing this, we're making public methods to work with private variables, right? That's called data hiding. You're hiding the data privately in the class and only making it accessed and modified through public methods. And that way you control the access to your variables. If it's sensitive information, it's kind of hidden from the developer, if you will. The developer cannot directly access the variables. They can only access them through the public means, that you give them access to it. Now, this is a standard getter and setter. This is a standard instance field. This is in object-oriented programming. This is very commonly done. Okay? You go back to, I first learned this in the Java class that I took in my high school that was in the 90s, right? So this is nothing new. Like, this is very traditional. This is still around, okay? Then they did come along, C# came along and said, there's kind of a more efficient way of doing these getters and setters. And we're gonna make these things called a property, okay? And the property does the same thing as the getters and setters, but it does it in a more condensed syntax. And so remember, methods have parentheses. These properties do not. So a property looks like this. Access modifier, return data type. It has the same name as the attribute, but we're going to do capital. They have a get block and a set block. Okay, so inside of the property, here's our curly braces for the property. There's a get block and a set block. What is the get block? That's our read operation. What is the set block? That's our write operation. You're doing read-write operations. That's all we're doing here. So when we get, it's just going to be like this. Look, get breed, what does it do? It returns breed. It does the same thing here. Return underscore breed. And we do a set. We set underscore breed equal to value. Notice here we set underscore breed equal to breed. Notice here we set underscore breed equal to value. Doing the same thing. You're putting data into something with this write block, this set block.
What is value in this case?
Value is the data that's passed in, right? So keep in mind, right now, we have not called this property. This property has never been used. But ultimately, somewhere in our code, we're going to do something like this. Whoop. We're going to say my dog.breed equals Shih Tzu. So the value in this case is what's passed into the property. Shih Tzu's in quotes, it's a string, so it's a string literal. So value holds a string literal of Shih Tzu. Good question. Does that make sense?
Yeah.
Okay, now let's demo this, okay? So here we have our class of dog, and we've got getters and setters, and we've got a property for that little thing. And so here's our form. We could view the code in our form. And so our form literally has no controls yet. We're just going to be coding everything. By the way, this is a special method called a constructor. This will come. This idea of a constructor will come up here in just a little bit. But here, let's just go ahead and say, I don't know, I guess we need a button click. And this will say demo dog button demo. So what's the syntax for creating a dog? We now have the blueprint created. Our blueprint has an attribute and some methods. Remembering that a method is a way to write reusable code of actions, right? You put a bunch of actions into a method. A class is reusable code that includes not only methods, but also attributes, data, reusable data. So all of our dogs have the same attributes now. So all that just to say, how do we create a dog using our new class? We have this class created. How do we implement it?
You would do like
Dog.
my dog
equals new dog. Yep. How about dog your dog equals new dog? Also valid. Now we've created two variables. The variable's data types is a reference data type. It's just a fancy way of saying it's a class. Okay, they're not ints, they're not doubles, they're not chars. This is a reference data type called dog. Here I've created two different dogs. What if I wanted to create 1,000 dogs? How would I create 1,000 dogs real quick? In an array. I'd say dog, kennel, right? K-E-N-N-E-L, is that how you spell kennel? So we have a kennel of dogs equals an array of dogs. And here, there's 1,000 dogs in this kennel. Poor dogs. Okay, we have created the array, correct. But do we not also, we need to create the dogs. This creates the array, but we haven't created the dogs. Remember, the second part of this is kind of important. You have to instantiate the 1,000 dogs with the loop, a lop. So let's go ahead and loop through our kennel.length, and we'll say kennel sub I equals new dog, and that's creating 1,000 dogs. This creates the storage for 1,000 dogs. This creates the kennel, if you will, the storage in your computer's RAM. So that's a good question. Like, what's the difference between this and this? Okay, this creates the storage in RAM. This actually puts the dogs in the storage. By the way, all of these dogs by default, they all have a breed. They all have a breed by default if you don't give them a breed, because breed is a string. Check this out. I'm just gonna show you something here. They all have a breed by default. I'll call this label result. And after I instantiate my dogs, I'll say label result.text, and I'll just pick my first dog, kennel sub 0 dot breed. This is the property. This is how we read the breed of the first dog. And we're going to put that into the text box. And I think you'll be able to see, well, it's an empty string. You can't see it because it's an empty string, but it's there. In fact, put a breakpoint in, maybe it'll show that better. Say empty string. I stand corrected, it is null. So null shows up as nothing in the... So strings are null by default. Let's just to... Strings have a default value of null. If I had another one like int dog age, how about that? Private int dog underscore age. We'll just say age. And let's make a property to access age. With a get block and a set block. The get block returns underscore age. The set is underscore age equals value. Pretty simple to create properties once you understand the syntax. And just to kind of go back into here we create all of our dogs, and let's set the age. We're gonna have to convert it to a string because this doesn't. Of course, what do we have here? We've got a string on the left and an int on the right. Age is an int, so we can't do that. We got to say toString. I'm just trying to show. There we go. So strings are null by default. Integers are 0. Doubles are 0.0. If you create 1,000 dogs, they all have default values. And that's different than your other variables. Like if I just had a method down here and I said in my method, I said int age. This age does not assume a default value, right? Local variables and parameters, they don't get default values, but objects, their attributes do. So that's just a side, yes.
Okay, so let's say you were creating like 5 or 10 objects. Would you have to loop through those objects and then, like, you were trying to assign values to them?
Yeah.
Or could you just assign the values to them rather than like doing a loop since you're only creating like 5?
You don't have to loop if you only have 5. You know, that's kind of up to you.
So it's not necessary.
It's not necessary. It's not necessary to loop, but if you're you're doing like 1,000, then yeah, you're gonna loop. But if you're just doing 5 objects, you don't have to loop.
Okay.
Good question. And so this is what we covered yesterday in 15 minutes. We covered classes, we covered objects, we covered attributes, properties, and getters and setters. Yep.
So the way that you put the, you did like 2,000 dogs into the array, is there a way you can be able to do that with a list so then you can like add to it?
The question is, can I make a list of dogs? Yeah, let's go ahead and say list of dog. I live in Illinois, so I'll call it IL kennel, Illinois kennel, equals a new list of dogs, as in that. Okay, and then here, again, this makes the list, kind of like making the array. Let's make a for loop to loop through our Illinois kennel.count. Now there is no count here because I have not added dogs, so a little bit harder there. But what you could do, ill kennel dot add. Now this is interesting. I can add my dog here because my dog is a dog. You could add it directly. My dog. Okay. What?
Dog is a dog.
My dog is a dog, so I can add my dog to the Illinois kennel. And so you could take the reference identifier, my dog, add it here. Okay. Or the other syntax, Illinois kennel dot add, and you can generate a new dog right here. And here, this is kind of another way. Okay, so a bunch of ways to adding things to a list. I think the question is, can you add them to a list? The answer is yes. Right now, this list has no dogs in it. This adds one dog. This adds another dog. But this dog doesn't have really an identifier. Like this dog has an identifier. This guy is just a position in a list. So the only way to reference that dog is to say, hey, Illinois kennel sub 1. That's how you reference that dog. There's a really cool syntax that I like, and to comment this out, so we're just back to our list. Because a dog has two things, a breed and an age. So you could say, let's see, new dog. You get the idea once you get it going once. You just got to get the syntax down. Good luck spelling Rottweiler. W-E-I-L-L-E-R. Sure, let's go with it. Age equals 15. So I like this syntax. If you know the data up front, you can just load your list full of your objects, which is kind of cool. That way you don't need this loop to, because this does this does two jobs. It creates the list and it creates the objects in the list. And it does it all in one nice, easy to go place. But you'll notice here what I had to use for this syntax was properties. I had to use the properties. Without the properties, I could not use this syntax. Once I've created, okay, so that's my list, and that's my array. And what you would do once you, like here you got 1,000 dogs, again, that's a lot of data to put in. And so we're not gonna put all that data in, but let's just do it for one dog. Okay, so now that we've got an array of 1,000 dogs, and we've created 1,000 dog objects in that array, keep in mind all of the dogs, all the 1,000 dogs, all of their breed is null and all of their ages are 0. Okay, so they have default values, and then that's, I think, important. But let's just say, okay, kennel sub-0 dot breed equals Shih Tzu, and kennel, this is our first dog, right? Our first dog has a breed of Shih Tzu, and our second dog has a breed of Rottweiler and an age of 15. So now our list has 2 dogs in it with the same kind of thing as our array. That's using the properties real quick. Okay, gosh. Yeah. What if I don't want to use the properties? The other option was the setter, set breed to Rottweiler. Set age. Did I not do set age? I didn't do a set age. So let's do this real quick. Public int get age, return age, public void set age, int age. This is kind of a, you could add the keyword this. This is a good time to talk about the keyword this. It's not necessary. Like you saw that, this was my syntax before, but very commonly you say this dot. When you see this dot, it always refers to the instance variable. What it means is you got 1,000 dogs, but this dog's age, meaning the instance variable for this particular dog, you got 1,000 dogs, but this particular dog's age is what's passed in. So the instance variable for this instance. Okay, so now I've got get age and set age, and that allows me to call set age. So you see the syntax difference between using the methods and the properties. All right, so now we're at 24 minutes. How are we doing? Good review? Yep.
Which one, like, would you use normally, like?
I would say if you're coding C#, you're going to see a lot more properties. Okay? They're just a more modern solution. The syntax is condensed. Yeah. You're going to see, and by the way, we're 30 days into this class. We'll be using properties for the next 50 days. Very common. All right, so label result.text equals, here we'll do a string, and our first array holds let's loop through our array, mydogs.length, or I'm sorry, kennel.length. So we're looping through our dog kennel, right? Label result.text plus equals put in a line break here. Dog breed is going to be kennel sub I dot breed comma dog age kennel sub I dot age. So these are using the properties. We're looping through our array using the properties and putting in the two, pulling out the data of our dogs. Now, what do we have here? A bug. Let's find it. Kennel.length. Oh, there it goes. There's 1,000 dogs. Do you see what it's doing? It's freezing my computer. It's trying to print out 1,000 dogs
On one line.
with an age of 0 and a breed of null. So I wonder if my recording's going to catch that. That's funny. Let me end the task. Instead of having 1,000 dogs in my kennel, let's just put 2 dogs in my kennel. And now we'll loop through the 2 dogs. Dog breed Shih Tzu, dog age 12, dog breed Rottweiler, dog age 15. So that's the output, right? So this is the data in, this is the data out. And then here, we'll append our second array holds, put in a line break here. And this is Illinois kennel, not the length, but the count. And instead of using the properties, I'll use the get breed method and get age method, just to, show something different. So we're looping through the list and using the accessor methods. So this would say our second list holds. Get the idea. Okay, what's new today? Keeping my promise, I've got 30 minutes to go. We said we're going to keep it to an hour, so we're at 30 minutes. So what's new? Right now, everything for our dog class, to set the breed and to set the age, you have to call 2 different things. You have to either call the mutators or call the 2 different properties. Right, so we did that here. We said, okay, here's the property, here's the property. And this is a nice condensed syntax, and this isn't so bad. But this is kind of a newer C# thing where you could take these properties and put them in curly braces after the constructor. So this piece right here, maybe you were wondering, like, let's break down this line. I'm just looking at this line, so let's look at line 22. The first part here is the data type of dog. The second part is the identifier. That's what the name you get to give it. You get to give the name of the identifier, right? There's rules and conventions around that. Then you have the assignment operator, which is the equal sign. So it assigns a value. Then you have the keyword new, means you're creating an instance of an object, of a class, excuse me. You're creating an instance of a class. So the keyword new says, hey, I'm actually creating an instance of my blueprint. So I'm going to use my blueprint and create an instance of it. And what do you do? When you create an instance of a blueprint, you're creating an object. So you see the keyword new, you're creating an object. That's what you're doing. The last piece, this piece right here, that's a method call. And that looks like a method call. Like literally, you've called methods before. And so you're calling a method here. There's a method called dog. And wait a minute, go back to my dog class. I don't see a method called dog. And that's because that's correct. We have not created a method called dog. However, all classes automatically get a method that has the same name as the class. It comes for free. You don't have to code it. It's just default. It's default. It's literally called the default constructor. The default constructor is just a method, and it's a method that has the same name as the class. Vinny, what's up?
So, for the sake of these labs that we're going to be doing, should we be using properties or like the more condensed or just like
The labs will tell you in that UML diagram. It will tell you whether you should be using properties or methods in that visual box that you saw.
Okay.
So if it has parentheses, then you know it's methods. If it doesn't have parentheses, it's talking about properties.
Yeah, but you know how like you have I forgot what the other one's called, but like the get set is the more condensed way to make a getter and setter.
Yeah, these properties are more
Can we always
condensed
do that?
than this.
Yeah.
But basically, these properties, again, so I'm just going to repeat. The lab will tell you which one to use. Because I do think it's important to know both. And so I don't want you only using one, because you'll see both of them out there, so you should get familiar with them both. So let's check this out. It says there's 5 references to this default constructor. So this is something I didn't have to code, but I just wanted to show you what it looks like. Now this method is really unique. This is a very unique method. Again, it's called the default constructor. You'll notice that there's 5 references to this method. Well, let's go look at where those 5 are. There's one. This is one reference. I mean, I count 1, 2, 3, 4. Am I missing one? 5. Do you see when I highlight this right here? I can literally count all 5 references. So again, this is a method call. Basically in the code that's associated with the form. So the class, you get this method for free. We didn't have to code it, and this method was able to be called 5 times. And so this is just part of creating an object. You just learned this syntax. Again, when you learn the random class, like you just learned this syntax and you didn't ask many questions. You just learned this is how you create an object, you know, and it helps me generate random numbers. And you're calling the default constructor right here. Okay. This constructor, default constructor, so new information. What is the purpose of a default constructor? Can be used to initialize our instance fields with data. So keep in mind that when we create our dogs like this, We said those instance fields have some default data, right? Maybe that's okay. Maybe that's what you want. Maybe you don't want that. Maybe you don't want all the instance fields to be null and 0. So you can create this. Our mutators put data into our fields, but they don't do them when the object is created. It does it later, right? This constructor, it says, hey, when the object is created, put the data into the fields. And so we learned about method overloading. Method overloading is when you have a method with the same name but a different parameter list. Remember method overloading. So guess what? We have overloaded constructors. We've used overloaded constructors. So let me write an overloaded constructor, show you what it looks like. Public dog, string breed, comma, int age, underscore breed equals breed, underscore age equals age. Okay. What are we doing here? We're putting data into our instance fields, just like we did with our mutators, right here. But we're just doing it at a different point in time in the object's life. This says, hey, as soon as this object is created, put the data in. Yes?
So is that's still a getter and a setter?
This is only really a setter. This is not, so as far as what is this doing, this is setting. This is a setter. Do you see how it's setting the data?
Yeah.
It's not a getter. We're going to learn the getter side of this. So what is the difference here? Okay, there's two differences. Number one, these setters, the set breed, they are typically working with one field at a time. But a lot of times we got a lot of fields. Like let's just say you got 20 fields or 10 fields, right? This constructor can set all of the values all at once. So that's the main thing. That's one thing, is it can work with many fields. It's not just working with one field. And it does it at a different point in the object's life cycle, right? So an object is created, an object is used, and an object dies, and then it's garbage collected, right? Meaning it goes out of memory. So this constructor has 0 references. We have not used this constructor. Let's use this constructor. So here I said, let's just bring it back here. Here's creating 2 dogs with the default constructor. You now know what this is called. This is called the default constructor. Let's create a dog called boss dog. We got boss dog. Okay. Look, as soon as I got my cursor in here, it sees. Now I've got an overloaded constructor. And now I can pass it a breed and an age inside of this constructor. I could say, what kind of dog would be a boss dog? Doberman. D-O. Chihuahua. They think that they're boss dog. All we're doing is this constructor does the job of multiple mutators. Does that make sense? It does the job of multiple mutators. We can use this as soon as this object is created, we can put the data in. So those default values are never assigned. It's always assigned a data that we give it. These dogs have default values. This one has some data put in immediately. Vinny?
So is this like just avoiding having to do like, get breed, get age, like you just do it all in one? Is that what?
Well, set breed, set age. Because again, this is kind of doing the job of the mutator.
Mm-hmm.
It's not doing the job of the getter.
So like if you wanted to.
But we are going to do the job of the getter.
If
So
you wanted to do like an infinite amount how many toes they have, how many legs.
Yeah, yeah, yeah.
It's like, are you able to? Is that what this is like doing? Is just getting around like having to create a new, I don't know the word for it.
A new method for every one of those.
Yeah.
So let's do that math. I'm gonna expand on that. So here we've got 2 attributes. So let's just do the math. 2 attributes, and for every attribute we have 2 methods, right? So let's say we've got 30 attributes, which is feasible. We've got 30 attributes. Therefore, if we're doing a getter and a setter for everyone, that's 60 methods. Okay?
A lot of extra code now.
So maybe instead of doing 60 methods, you might just write a couple of overloaded constructors. And that's reasonable, right? So it's just, it really boils down to, it's kind of multiple ways of doing the same thing. Because ultimately, what are we doing? We're putting data into these attributes. And so you can put data in. Now you've learned 3 ways of putting data in. You can put it in through a constructor. You can put it in through a property, a set block of a property, or a mutator method. They're all doing the same thing. They're all doing the same thing, just in different ways.
Can you go back up to the constructor?
Yeah, let's look at the constructor here. There we go.
So that's within public, or no, that's
Yeah, this is still in the
okay,
class.
that's in the class.
So you define the constructor in the class. You get the default constructor for free. But it's also worth noting, you only get it for free when you don't code a constructor. Do you notice I've coded this constructor now? Watch what happens. This no longer, there's 5 references to this. So if I delete this, I no longer get it for free. It's just a weird kind of thing. Look at this. The default constructor now errors out. So if you code your own, sorry to cut you off there. If you code your own constructor, as it turns out, you have to code the default, public dog. And now this isn't erroring out. So you get the default constructor for free if you have no other constructors. As soon as you add your own constructor, you no longer get the default for free. One more thing worth noting, you might have scratched your head at this. The constructor is just a unique method, and one thing that makes it unique is it has the same name as the class. That's always the case. The constructor has the same name as the class. Another thing, it has no return data type. All of our other methods either have a void or an int or a string. It has a return data type. Constructors have no return data type. It's just access modifier, name of the class, parentheses. Josh, you had a question, or did I
Well, no, I
answer?
was just gonna say when you deleted public dog,
Yep.
all the references went down to the other constructor.
It did. It tried to use the other one,
But you still have to go in and like.
but then you can't. Yeah.
So are those properties that are within the constructor, or no? That's not property. Attributes that are within the constructor.
Like right here,
Yeah.
I would call that a string literal. That's just a string literal.
Okay.
Let's do this. I just want to kind of show you here. I'll put in a breakpoint right here. Okay, so I click the button, and this is going to generate a dog. So if I start with debugging, it's just kind of neat to watch it flow. And so just watch the execution. So line 29, I'm going to step into line 29. Notice where it goes. Default constructor. I call this one. Notice where it goes. Breed holds Chihuahua. Age is 1. So we set the instance breed equal to the parameter Chihuahua. And we set the instance age equal to the age of 1. So now underscore breed and underscore age for that dog have values. 15 more minutes, and then we're done. So what's new today? What's new today? Constructors. What are constructors? Constructors are a way of writing a mutator for multiple instance fields. In theory, you could have a bunch of constructors. You could say public, dog. You could have a constructor that just takes in the breed. But, you know, you're kind of just showing you can have that. Just because it's an overloaded method, you can have as many overloads as you want. But it doesn't always make sense. I'm just showing you that you can. As long as it follows the rules of overloaded methods, you can do that. Yep.
So like, could you do like everything all in one overloaded method? Breed, age, how many eyes?
Yeah, if you had 30 attributes, you could put 30 attributes in here.
Is that like a bad practice to like overload it that much?
No, because again, so if you let's just take a look because I just keep going back to my random class, because that's one thing that we've used a couple of times. How many overloaded constructors do we have here? Okay, we just have 2. We just have 2 overloaded constructors on this one. And that's a seed and a time-dependent default seed value. So there's kind of 2 ways of writing that. What's another class that we've used? Math, right? Actually, math, you never use this one. You would just say math.abs. Now, this is just a complete side note. This is a complete side note. Depending on the method, notice here, in order to call our methods setBreed, we did that by instance. We had to create an instance of the object, and it would be instance.methodName. But here, we didn't have to create an instance of the math class, right? Notice here, we just say math.abs. We did not create an instance of math. And that's because when you mark a method as static, that makes you, that changes how you call the method. So this is, a lot of the methods in the math class are marked as static, which means you just call them differently. Okay, that's a side note. Last piece of new information. In addition to constructors, Vinny made the point is, hey, if I've got 30 attributes, can I write one constructor to put all the data in at one time? The answer is yes. You could write one constructor to put all the data in, which leads your brain to the next logical place, which if there's one way to put all the data in, can there be one way to pull all the data out? And the traditional answer is yes, there's one way to get all the data out. And the traditional way of writing a method is called ToString. And a ToString method is like a get operation on many attributes, or all the attributes. So if a constructor is a way of putting all the data in, you could think of a ToString as a way of reading all the data out. And so what's all of our data? Our data is the breed and the age. So let's write a ToString, public, and this one, it's got this keyword override here. That is an important concept that we will cover for right now. It's just a part of the ToString method header. We will dive a little bit deeper into that. So I don't know, we got a dog. I mean, we want to return the information on the dog. You would say return, because it's a return data type of a string. The dog's breed is _breed. Notice how I'm using the instance fields? Because I'm in the class, I could just use the instance fields that were set here. So I made this method called ToString that's going to return both the breed and the age, and you could return as many pieces of data as you want. So again, in summary, I think it's an easy high-level concept to understand. Hey, a constructor puts a lot of data in. A ToString can pull a lot of data out. And how do we work with the ToString? Well, notice down here, we're kind of writing a ToString. Right here. This is a manual, like this is calling multiple accessors. Like, let's just do this. Here we got a loop, we're looping through the Illinois dogs. I'm going to take that out, and I'll say Illinois kennel sub I dot ToString. And so that's probably a more complex scenario because, again, we're in a list here. We're in a list of objects, and so we're targeting the first object and calling the ToString method on that object. So this is our second list. I just want to show you that it works the same way, but the idea is you write this ToString once, and then you don't have to call a bunch of, like in this case, only 2 different accessors. But if you've got 30 fields, and you'd have to call 30 different accessor methods instead of just calling one ToString method. It's also worth noting, if you just print an object like this, there's an implicit or automatic call to ToString. So you could just print the object name, and that works. So let me simplify this because it's a little bit harder to see it inside of a list. I'm going to take out my loops here. And here, I'm just going to focus on boss dog. So boss dog, we use the constructor to put data in. And I'm going to say label result.text equals bossdog.ToString. And that's going to pull the data out. So multiple pieces of data in, multiple pieces of data out. Constructors and ToStrings. That was the new information from today. Again, let's take a look at the ToString. Keep in mind, I didn't really cover in detail what this keyword override means. In fact, I think you can leave it out, and I think it'll be all right. It just kind of suggests it. Kind of wants you to do this. Yeah, so let's just keep it in there.
Is that because there's like a default method of ToString?
There is a default method ToString. So I don't even have to write this. Like if I take this out, you get a default ToString method, and it's still, but it's kind of a useless method by itself. If I just look at this, like that doesn't work.
Right.
Like what are we looking at here? The default implementation of ToString gives us the namespace and the class name. That's not useful information. We want information out of our object. And our object's information was the age and the breed. Cool? All right, guys. Let's go ahead and stop that.